Hi everyone, so this is the lesson 18 problem set. Now I know that in lesson 16, 17, and 17, I went ahead and I drew some of the figures in each box with kind of the attributes that they were asking for. And I'd like to skip that for today's problem set. I think in the previous videos, in the mini lessons for 1 and 2, we covered these things. So we covered drawing a rhombus with no right angles. So that was this first drawing. So this was an example of a rhombus with no right angles. A rectangle with not all sides equal. This was an example of a rectangle with not all sides equal. A rhombus with one right angle and a rectangle with all sides equal. Those essentially are going to be a square. So for C and D, both of these could be a square. And again, this gets kind of tricky. Try and do it like this. 1.5 to 2.5. Because I'm trying to get this as perfect as possible. Trying to be precise. And so if I did my line, I started at the half. Oh yeah, I probably should have done this first. Okay, so from the half, I did from the half to 2.5, I think. That's what I should have done. Okay, so essentially, I think I was making these 1.5 inches, or 2 inches. I was making it 2 inches by 2 inches all the way around. 6 to 4, perfect. Okay, so both of these, now we've talked about a rhombus. All side lengths are equal, okay? So these were all 2 inches. And if we're drawing a rectangle with all sides equal, well, then all sides have to be equal. And then because all sides are equal, all of these are going to be 90-degree angles. So this one square takes care of both of these. And that should kind of tell you something that we haven't quite talked about yet, is that squares are rhombuses. Okay, so we'll explore that a little bit later. But what I really wanted to focus on was question 4. Because question 4 is the question that helps us really think about these shapes as we're drawing them and really think about their properties and kind of cements our understanding of what makes a shape what it is. So question 4A lists the properties that are shared by all rhombuses that we worked with today. So we're going to put straight sides of equal lengths. That is kind of key. To be a rhombus, your side lengths have to be the same. So 4 straight sides of equal lengths. When we think of, even if we look back to this one, our opposite sides are parallel to one another. So these are parallel, these are parallel. So we have opposite sides are parallel. And again, the reason I'm focusing also on question 4 is one of your Zern lessons that you will do is all around attributes and being able to say true or false to specific questions regarding shapes. So I definitely want you to know the attributes. Now, when we looked at our rhombus, we did some work with diagonals and we learned that the diagonals are perpendicular bisectors. So diagonals are perpendicular bisectors. And then with those perpendicular bisectors, the angles add up to, or the angles next to each other, because I want to have that thinking, next to each other equal 180 degrees. And then of course we know all four angles equal 360. Okay, so list the properties that are shared by all rectangles that we worked with today. Okay, so if we even just start with this, rectangles have 4 straight sides, but a rectangle doesn't have to have equal lengths. So 4 straight sides. And then opposite sides are equal length. Okay, we know that opposite sides are parallel. One of the big things has 4 right angles. That's a key thing. 4 right angles. And then diagonals. This was the other thing we learned. The diagonals are equal. And bisect each other. Okay, a lot about rectangles. So here we go with some of those questions, because this is, you will get these questions, I think it's lessons 20 and 21. When can a trapezoid also be called a rhombus? So a trapezoid, in order for it to be a rhombus, it has to have 4 sides the same length. Okay, so a trapezoid is also a rhombus when it has 4 sides of equal length. When can a parallelogram also be called a rectangle? So this is going to have to do with the angles. A parallelogram is also a rectangle when it has 4 90-degree angles. Okay, last one. When can a quadrilateral also be called a rhombus? So now we're going to our most non-specific shape, quadrilateral, shapes that have 4 sides. When can it also be called a rhombus? So a quadrilateral can also be a rhombus when all 4 sides are equal in length. So you can see that's kind of key. It keeps coming back to what makes a rhombus a rhombus. 4 straight sides of equal length. Like that's the key. You are a rhombus if all of your sides are equal length. Okay, so last thing I want to show you, and I wish I wouldn't have put my book away yet, is that hierarchy template, because we just learned some new things. So this is the last thing I'm going to show you. I'm going to let you go. Okay, so again, we start out with, here we have our quadrilateral, and we know that all of the shapes inside the quadrilateral are quadrilaterals. So a trapezoid is a quadrilateral. A parallelogram is a quadrilateral. A rectangle is a quadrilateral. We know that rhombi are quadrilaterals. And we even have a square in there. Okay, we haven't talked about squares yet. All right, but you can see that a lot of these things are the same thing. So we know that here's the trapezoids. So a parallelogram can be a trapezoid. A rectangle can be a trapezoid. A rhombi can be a trapezoid. A square can be a trapezoid. Okay, these are all things. They can be that because we know a trapezoid needs at least one pair of parallel lines, and all of these have at least one pair of parallel lines. What makes them unique is the fact that they have some of these other attributes. So we can also see that a rectangle is also considered a parallelogram because it has 2 pairs of 90-degree angles. We can see that a rhombi is also a parallelogram because it has those 2 sets. And so we'll keep exploring further and further with these attributes. Okay, so any questions? Go ahead, send me a message. Have a good one. Thanks.